Hello everyone, welcome back. In this video we're delving into fascinating world of data structure, and our focus still will be on linked list data structure. For beginners, linked list can seem quite complex, but once you understand the core concept, you will see how beautiful and efficient the linked list data structure can be. So without further ado, let's jump right in. Today we'll be talking about different types of linked list data structure, but before we get into the types of linked list data structure, let's quickly remind ourselves of what a linked list basically is. A linked list is a linear data structure similar to an array data structure. However, unlike arrays, elements in a linked list are not stored in contiguous memory locations. They are linked using pointers. Each element or node containing data on a pointer to the next node in the sequence. So basically, nodes or elements of a linked list are stored in non-contiguous blocks of memory. This structure allows for efficient insertion and deletion of elements. So basically, there are four primary types of linked list, each with their own unique properties. We have singly linked list, we have doubly linked list, we have circular linked list, and we have doubly circular linked list. So let's talk about singly linked list. Singly linked list, which is the most common used linked list, each node in a singly linked list contains data and a pointer to the next node or the next data element in the list. So data part of the node stores actual information that to be represented by the node, while the link part is used to store the address of the next node or its immediate successor. So now let's take a look how can we represent a single linked list using a class or a struct. So I'm going to use a class to represent a node of a single linked list. So I'm going to go to the Visual Studio and right click on project name and go to add, and I'm going to add a new class and I will call it node. So I can use a struct also to represent a node. So as I said, a node has a data part where we can store the actual data. So in data part, so I want to store only integer values and data, and also I want to I have a link part or the pointer to the next link part or pointer to the next node. So this pointer is going to be of type node. It's going to store the address of an object which is of type node. So let's call our pointer next. So this way we can represent a node of a singly linked list having only a single node and data part. So in data part we can store as many data as we want. So if I want to store double say salary or whatever, I can do that. So for simplicity, let's store only one data item, but we can store as many data items as we want in a node. Imagine I have three numbers 5, 8 and 80, and I want to store it in a linked list data structure. So what I can do, I can create three separate nodes, each node having a data part and a link part, and also each node is stored in a non-contiguous random memory locations. First node is stored in memory address 500, second node 700, and for example third node having an address of 900. So in data part of each node I stored my information, and in the link part or next part of each node I stored the reference or memory address of the next node to keep track of each node in the linked list. Also the first element or the first node in a linked list, also called the head node or the start node, and the last element in a linked list is called the end node or the tail node. To keep track of the elements of a linked list, we keep a pointer, usually called head or start, to the first element of the linked list. Remember, when I say head pointer, this head is not this is not a node, or it is not a head node. It is just a pointer to the head node storing the memory address of the first node. So in this case, this pointer stores memory address 500 so that we can have access to the first element of the array. In the previous video, when I said head node, I mean when someone says head node, he means the first node in the linked list. But when we say head pointer, this is just a pointer to the first node, so that through this pointer we can traverse to the linked list. Same way, to keep track of the last node in a linked list, we keep a pointer, usually called tail or end pointer, that points to the memory address of the last node. In this case, this pointer, this is not a node, this is just a pointer to the last node. So in this case, this tail pointer is going to store memory address 900, so that we can access the last element of the linked list through this pointer. As the name implies, a singly linked list having only a single link or a connection between each element, and also traversing only a unidirectional or forward traversal is possible in a singly linked list. So we can start traversing from head pointer going all the way to the tail or end pointer. So only one way traversal is possible. We cannot traverse backward in a singly linked list, since there is only one unidirectional link between each node in a singly linked list. Next, we have doubly linked list. Unlike singly linked list, each node in a doubly linked list contains data and two pointers. One pointer to point to the next node, and other pointer points to the previous node. So in a doubly linked list, each node contains three parts. Basically, one part is for data or storing information. We have one pointer pointing to the next node, and we also have another pointer pointing to the previous node. So say I want to store three numbers in my linked list. So what I can do, I can create three separate nodes. So when I create a node, I have a data part, a previous part, and a next part. So in the data part, say I want to store number 5, this node will be stored in a memory address 600. And so initially the previous pointer will point to null, and the next pointer will point to null. So when I want to add a second number, I create a new node. Say I want to store number 6 here. This will have a memory address 700. When I create the new node, this will also point to null, and this will also point to null. To connect these two data elements or two nodes in a doubly linked list, so the next node of the first element or the current element is going to point to the address of the newly created node. So in this case, 700 will be stored in this memory address or this pointer, and the newly created node's previous pointer is going to point to the address of its previous node. So in this case, the previous node to this node is going to be number 5. So the previous pointer of newly created node is going to point to address 600. Also, if I want to store a third number, say I want to store number 70, I create a doubly linked list node. This node will have an address, say 900. So initially this will be null and this will be null. So to link this, the current node's next pointer is going to point to the newly created node. So in this case, node having number 6 is going to point to node having number 70. So in the next part of this node, I can store address 900, and the previous part of this node is going to point to its previous node. So in this case, the previous node having address of 700, so I can store 700 here. This way, a double linked list or a double way pointers are created between each node. So the first node having no previous address, the previous part of the first node will point to null, and also the next node of the last element or tail element or tail node points to null, since we are not pointing to the next element, and also the first element doesn't have a previous element. Same case, we to keep track of the data elements, we always keep a pointer called first pointer or head pointer pointing to the memory address of the first element. So this head pointer is going to store memory address 600, and usually we also keep a tail pointer pointing to the last element in a linked list. So in this case, tail pointer is going to store address 900. To represent as doubly linked list node while writing program, so we can just simply add another pointer to this node. We will have our data part. In the link part, we will have two links or two pointers. another pointer of type node. So this is going to be a pointer storing the memory address of an object of type node. So let's call it prev or previous pointer. So this way we can represent a node of a doubly linked list. Also remember that in a doubly linked list, two-way or bidirectional traversal is possible. Since we have two link between each node, we can either traverse forward or either we can traverse backward between each node in the doubly linked list. Next, we have a circular linked list. As the name suggests, it will have a circular shape while connecting the nodes. In this type of linked list, the last node in the list points back to the head node or the first node instead of pointing to the null. This creates a closed loop or circle. This can be useful when the list needs to be traversed from the end to the beginning and vice versa. So basically, a circular linked list or a singly circular linked list is a type of singly linked list, but instead of the last node pointing to the null, at this time the last node points back to the first node. So we are going to close the loop. Instead of pointing to the null, so the last node is going to store the address or memory address of the first node in this case. So this pointer is going to point to memory address 500, forming a circle or a loop. So in simple word, circular singly linked list is a type of singly linked list where the last node points to the first node. Lastly, we have doubly circular linked list, which combines the feature of doubly linked list and a circular linked list. Each node has two pointers, again just like a doubly linked list, and the last node points back to the head node and the head node points back to the last node, like a circular linked list. This structure allows for bidirectional traversal even from the end to the beginning and beginning to the end. So it is just a type of doubly linked list with few modification, having instead of the last node pointing to the null, this time in a doubly circular linked list, the last node points to the first node. So this next pointer is going to store number 600 or memory address 600. So this is going to point to the first node, and the first node's previous pointer, instead of storing null here, we store the address of the last node. In this case, first node's previous pointer is going to point to memory address 900, forming a doubly circular linked list. So to represent a doubly circular linked list, is going to be the same node representation with few modification. While we define the first element and also the last element of the linked list, we will see the implementation of doubly linked list and doubly circular linked list in the future videos. Thank you guys for watching, and see you in the next video. Bye bye.